Hey, we're about to do Google Kickstart. It's round E for 2022. We get started in a couple seconds here. So yeah, let's jump in. All right, here we go. 4 problems. Just start with the second one, why not? Shows one mentor. Okay. J can be the mentor. Oh, they can't be too much better. Is that it? I see. Okay, so yeah, I see. So then I think this is not possible. I think we just outward vector mentor. The way I did this is a little bit weird, but I think it works. All right, let's just jump around. One empty palindrome. P combined with Q forms a palindrome. Non-empty, non-empty. Okay. Cool. So sure, I guess I could do this with my string hashing. It seems like an easy enough way to set it up. All right. Oh, Q has to be a palindrome. Q has to be a palindrome and P has to be a palindrome. That's very interesting. Q has to be a palindrome. So P is a palindrome. Well, P is a palindrome and Q is a palindrome. So I didn't read this properly. P is a palindrome. Q is a palindrome. Okay, so certainly you could add itself to it. Okay, I see. So that has a palindrome, that has a palindrome. So this is P, I guess, whatever. So if I understand correctly, what happens is plot plus plus and minus minus. This is basically what happens, right? I could have been smarter and used division, but whatever. N by N. P pizzas. Customer lives there and basic coins. Yep. P pizzas. Deliver all of them. There's a toll system. Did I get a wrong answer? What? Did I get it wrong? What did I do wrong? I didn't have 6 correct. 1 to the bottom. Okay. Oh, what am I doing? Moves 1 and then takes that. So it should really be. Number 5. Yeah. What am I doing? Oh, so bad. I got a 4-minute penalty for doing that. Oh, that's so bad. Okay. Add minus multiply integer division. What's n? It's a 10 by 10. Okay. There's 20 minutes. That's where she starts. So she has to do it. She has to do all the pizzas, and P is up to 10. C is up to CK. What is CK? What is CK? I'll give her CK coins. Okay. KD. Do you always want to have as many points as possible? Well, given that you can add and subtract them, yes. Multiply, still yes. And divide, still yes. So you should just always try to have as many points as you can. So you have a DP on, it's this time, I'm at this location, I've delivered these pizzas. What's the most number of points I can have? I think that's it, right? 10 by 10. So what is that? What do we have here? We have 20 times 10 times 10 times 2 to the 10. That's number of states, something like that. Yeah, that seems fine. Okay, so seems okay. Relatively straightforward DP solution. Okay, let's go for it. What's the input? npm ar AC. Or the just TP of 0, sorry, ARAC with nothing. No, not min, that's not a good name. North, east, west, south. North, east, west, south. Excuse me. Alright, so I'm going to keep going to the input. All right. Oh, yeah, I think so. Oh, this needs to be. Now there's also just an option to stay in place. All right, so let's hear that. So we apply op. So when you move the apply op, we change the mask, and then we Right? I'll put 9. How do we get 9 here? Oh, we can choose not to do pizza. We've got more, that's the thing. Oh. We can't do it twice. Is that one? Oh, running into some issues here. So we have to debug. Alright, now. Yeah, you can just do nothing, or you can go in each of the directions. Oh, sorry. This is supposed to be and. What am I doing? Eight impossible one. 0, right? Alright, let's hope it's right. And I have to wait 4 minutes to see if I win. This person doesn't have a penalty. Alright, finished. Still have to wait 4 minutes to see if I win. I have a 29-minute, 50-second penalty time. In the meantime, we'll talk through each of the problems. Let's just open them up here. All right, cool. So, problem coloring game. So in this problem, we've got John, and he likes games. And there's n cells from left to right in a row, numbered from 1 through n. Everything starts white, and it's valid. A cell is valid if it's white and nothing next to it is red. And on your turn, you can paint any valid cell red. The game ends when there's no valid cells left, and the score is the number of cells you painted. John's playing against a bot. The bot is silly and always paints the first valid cell from the left. John is trying to make it as hard as possible for the bot, and so we basically want to see what's going to happen in this arrangement. So simulating this, if you think about this, it's actually pretty simple what happens. Basically, there's a bunch of cells, and the bot will paint the first cell red, which eliminates the second cell. And John just has a greedy strategy where next the bot would paint this and then make this cell unusable. But John wants to stop that. So John could play here, in which case the bot will play here. But an even better thing for John to do is to play here, which knocks out both this and forces the bot to go here next. And then we can repeat the same thing again. So John skips one. And you can see each time we do this, we're knocking out 5 of them. Every time the bot gets one. And then finally the bot gets one more when there's 5 or fewer left, and that is the end. And so this is actually really simple to simulate. We can do this, and basically while there's at least one cell, the bot paints 1, and then n decreases by 5. And we can actually make this, so it's a simple greedy idea here. We can actually make this constant time by using division. So let's see, what would we do here? Basically, bot is going to be n divided by 5, because for every full chunk of 5, we get 1, and then if there's extra left over, we'll have 1 more. So it'll be n mod 5 not considered. And that is the answer. And I think we can just submit this. I don't think this will affect our penalty. So what the heck, let's do it. So let's see. Yep, it passed and it did not affect our penalty. And actually, we have about 40 seconds left for anyone to pass us. So it'll be interesting to see. But in the meantime, we'll talk about problem B. So that's problem A. Problem B. So problem B, there's n students. Oh, what happened? N students, and each one is looking for a mentor. The mentor needs to be one of the other students. And for each student, we know their rating, which tells you how good that student is. And this is not what I would, this is not how I define a mentor, but apparently Google defines a mentor as someone where their rating, the mentor's rating, is at most double the mentee's rating. If the mentor's rating is more than double, then that is too much and they cannot be their mentor. And then every student wants to have the strongest possible mentor. So we need to figure out for each student what is the highest possible rating they can pick as a mentor out of the other students. Okay, so the thing to watch out for here is that n is going to be up to 10 to the 5th. So we cannot do anything quadratic. We cannot loop over all pairs and check all of them. We need to do something more efficient. So in this case, what we're doing is we're using binary search here because we can binary search for double their rating and find the biggest number that does not exceed that. So it's a little tricky because you need to avoid yourself. So first we're going to read the input. We're going to take the sorted version, and then we're going to build what we're going to do. I think we can simplify this a bit, but anyway, what I do is I search for upper bound on 2 times r. What that does is that finds the first position greater than 2 times r, and then we kind of want to back up a little bit. this can never happen because the student's own rating is inside, so I can actually just eliminate this. So assert it, sort it out again, and this can help us apply our code. So, okay. Cool, that's better. So, first of all, so this is the biggest number that is at most 2 times r. First of all, if that number is not r, then we know that person is not our original person, so we're fine. We can just use that as our mentor. Is this possible? It equals, yeah, if the person is r, and that is the smallest value in the array, then the only person who has at most 2 times r is themselves. So then they have no mentor option. So it's going to be a -1. Otherwise, we can go back down one more time and then pick that number basically. Because the idea is if r is the biggest number that is at most 2 times r, but there's another number right before that, we can pick that number. And this is a bit weird because we're having a mentor who is lower than us, but that should be fine, according to the problem's definition. In particular, 2000 picks 1900 as their mentor. So now when we set it up this way, this just runs in n log n time, so this is very efficient. And we can also just submit this, just for the heck of it. In the meantime, we can see what happened. Okay, it looks like we did secure the win. Cool. And let's see what happened here. That does pass. Okay, cool. So now problem C. In problem C, it took me a while to read this problem because I was just being silly. But basically, you're given a string P. That string P is a palindrome. And now you want to find the shortest non-empty palindrome Q so that P concatenated with Q forms a palindrome. The string PQ. So P is a palindrome, Q is a palindrome, PQ is a palindrome, and you want the shortest possible Q. Okay, so what happens? I'll save this and go to this. So what happens here? So let's say, P is 8 letters long, and then we want to, we're going to loop up the length of Q from 1 to n. Obviously, P concatenated with P does work because P is a palindrome, and so that is going to work. That is helping us guarantee there's always an answer of length at most n. So let's loop from 1 up to n and check for each length whether it works. So let's say, for example, we have a string P of length 8, and we're trying to check if Q of length 5 works. So first of all, what we need is that Q is a palindrome. And what is Q? Q is actually the reverse of the first 5 characters of P. The reason for that is that PQ is a palindrome, right? So Q is the reverse of the first 5 characters of P, but Q is the first reverse of that, but Q is also a palindrome. So that means that the first 5 characters of P needs to be a palindrome. Okay, and then also, once we kind of shave these off, the remaining characters of P also need to be a palindrome. And if both of these are true, this is a palindrome, and this is the reverse, which is itself, and this is a palindrome, then our whole string is a palindrome. So all we actually need to check is that we need to cut up the string into 2 pieces, a prefix and a suffix, where both are palindromes. And we want to find the shortest prefix where we can do that. So that's actually what I do here in my code. In this case, I'm using string hashing in order to basically check if something is a palindrome in constant time. It just hashes the substring of the string and the reverse of the substring and checks if they're the same. And so this way, these checks are both O of 1 constant time. And this gives me O of n time for my solution. And I just check from 1 to n, see if it's it breaks it up into 2 palindromes, and then if so, we're done. There are other ways to do this too. There is Maneker's algorithm. Maneker's algorithm gives you a linear time algorithm. It's kind of, the idea is to kind of update an umbrella in the algorithm. I won't get into details of the algorithm, but you can look it up if you want. It's spelled Maneker like this. And it gives you the length of the longest palindrome at each center point. So From that perspective, I could also do this with manicure. So let's go ahead and do that. Copy this as C hash, and then we'll now do this with manicure. This uses combined manicure, so we're going to go ahead and do that. And that is going to shorten this code quite a bit. Combine manicure on P. And now this should work. Let's give this a go. Submit this. This is Nick Wu. Looks like he's solidified. No, not quite yet. But oh, he got 2 penalties, that's why. So he's sitting in second place. He's not a solid second place yet, but he will be in about a minute or so. And no, he is not my brother. Okay, so that is this is also a viable solution. This is also OLN. And the code is much shorter. This is sort of some crazy string algorithm magic, but a couple ways to do it. All right, and lastly, problem pizza delivery. So here we have an n by n world, and we have p customers that want one of each of p pizzas. We know where each of the customers lives. We know how much they'll pay us for the pizza. We know where we're starting, and we're starting with 0 coins. And we have p pizzas. We want to deliver all the pizzas within m minutes, and we need to drop off pizzas, move around, and we're not allowed to go out of the grid. A couple other guarantees to help make things a little easier. We can stay in location and not move. So we have basically 5 choices every minute. We can go north, east, west, south, or stay. And then also we can reach a customer's location and decide not to deliver the pizza yet, which is an interesting condition here. And then they have a very strange toll system when you use the streets. Basically, when you go north, east, west, or south, each of those 4 directions has a function that affects your number of coins. That function can be adding some fixed number, subtracting some fixed number, multiplying some fixed number, or dividing some fixed number. So in fact, the toll can increase how many coins you have, which is really weird. But in any case, you're given these definitions up in advance. It can be something like this. There's also division. Division uses for division, which they note here. Figure out if we can deliver all the pizzas within m minutes, and then if so, you figure out the maximum number of coins we can have after exactly m minutes. So a couple key things to note here. All of these numbers are very small. It is at most 10, so a 10 by 10 grid. We have at most 20 minutes. This is not as important, but the customers give you at most 4 coins. The operations work from 1 up to at most 4. So even if we multiplied by 4 20 times, we wouldn't get that big. 4 to the 20, or 2 to the 40. And then at most 10 pizzas. So this is a very classic dynamic programming problem. We have our state. The state is very multidimensional. The state is the time, the n by n location where we are, and the 2 to the p subset of which of the customers we delivered the pizzas to. So it's a combination of all of those things together. The time is implicit in this array because I just iterate the time. I do kind of a sliding window approach. And we initialize the initial location ARAC with no pizzas delivered, means we have 0 coins. And the state is the number of coins. So there's a key idea here that at any given moment we should, given where we are and the state we have, we should try to be maximizing, we should be trying to maximize how many coins we have. There's no situation where, given the same state, you will want fewer coins versus more coins. And the reason is, even with these weird functions, multiplying and dividing, adding, subtracting, the number of coins you have after the function is monotonic in the number of coins you have before. So if you have more coins before, then after the function, there's no way you'll end up with fewer. This would not be true if we could multiply by a negative number, because then, for example, let's say we're multiplying by -2. It would be worse to start with 7 coins than to start with 5 coins, because 7 times -2 is -14, 5 times negative 2 is negative 10, which is worse. In that case, things would get weird. You can still solve it if you tracked the minimum and the maximum. But anyway, the point is, because we don't have to deal with that, we can just optimize for the maximum at any given moment, and that's what we do. Yeah, and the rest of it is somewhat standard dynamic programming. We just have our states, we iterate the time, we have our new states, we iterate all the states n by 2 to the p, skip invalid states, this, and then we do our transitions. This represents staying in place. This represents the 4 directions. There are some good tricks to read these directions in a way where, first of all, order the directions the same way the problem says. Read these in, and then each direction is just 0, 1, 2, or 3. And we can make things into arrays. That makes things nicer. This is an abstraction to apply the op to a value. And basically apply the toll, right, in a certain direction. It just checks the different ops and applies it. Yeah, and so now here we can try the 4 directions, see where we go, make sure we don't leave the grid. And this part is a little tricky. This represents, even if this location has a customer, I do not deliver the pizza to the customer. And then there's also a little detail here. This would be the new mask if I do deliver, if there's a pizza here and a customer here, deliver that pizza. And now I need to be careful. I only add the benefit, the coins from delivering that pizza, if I haven't already delivered that pizza, which is represented by mask. So I don't want to be able to come back to the same customer again and again and get the same coins. And then we just transition that. Finally, after all this stuff, we replace our DP array with a new DP array, and then repeat. This is a sliding window idea. And then finally, at the end, we're just taking the maximum out of all DP states where we have delivered all the pizzas to all the customers. Yeah, and then we can just check for the impossible case if it's still negative infinity. So that's the idea. It's a multi-dimensional dynamic programming idea here, but once you understand the idea behind dynamic programming, this is a pretty straightforward application of it. You just need to work through a lot of details. So if this is your first time learning about dynamic programming, I recommend doing an easier problem. I think a standard good one is just calculating the Fibonacci numbers. So feel free to look that up. But yeah, that's going to be all the problems. Looks like Nick did get first or second. I did get first. Nick did get second. Now you got me confused. But anyway, that'll be it from me. Thanks for tuning in, checking out the video. Feel free to subscribe to the channel if you want to check out any more. And I also have a link to my Discord below. But otherwise, I'll see you in the next one.